This is video 3. We have done step 1. We have made sure that we can stop the robot. Now we want to do step 2, which is to start the robot. What does that mean? Well, let's go back to the demo and see what happens when we start the robot. Okay. So let's run it. And we're going to say start. And that's probably all we're going to do. We're going to say start. And what do we see? Well, first of all, we see that we get an output to the screen that says that we're starting in a certain position. Okay? So let's terminate. We know how to stop. So let's go and make the start work. For this, we need to go back into our code. And all of a sudden, we need to know that we got to keep track of the position. To keep track of something, we need variables. What variables do we need? Why don't we call them X and Y? And these are just the coordinates of the robot position. All right. What did the problem say? The problem said that the robot starts at 0, 0. So for this, we can just go ahead and declare these and initialize them so that they are okay. So if that's done, clearly, when we say start, what should we do? We should certainly output this line. When we start, we've got to say, where's this thing? Come on, man. Okay, here it is. We got to output something that looks like this. So start simply means before I break, I got to output something. Okay. Put your code for the switch, for the case, put it under here. So we got to output something that looks like this. Is it clear that we can't output what I'm putting here, but we can output something that looks like that? So what does that mean? We have to output, where in the heck am I? Okay, where is it? Okay, started at some position. Okay, now I've got to put the actual X position, the X coordinate, followed by what? A comma, followed by the Y position, followed by a right paren, and skip a line. Okay, that's what we got to do. I hate this thing, it's so crazy. All right, so we got it. Now, is that going to work? Let's take a quick look. Let's compile our thing. Let's compile it. So we've basically said I got to output the screen that I'm starting at the X, Y position. Let's compile it and run. Run it. And we're going to say start. Whoa, we're getting the output we wanted to see. And we're going to say terminate. Are we finished? Are we finished? No, because when we run the demo, you got to pay close attention now. When we run the demo and do the same thing, let's see what happens. We're going to say start and terminate. So we have output here, and remember there's two places where output can go. One is to the screen, the other is this file. So whoa, so it looks like this has to be written to the output file. The same output that went to the screen should be displayed, should be written after we write these 3 lines to the output file. Okay, what does that mean? Well, it means in your code you've got to go in and you've got to deal with the issue about the file. And when you do this, you must also produce the output for the output file. So we have more to do right here. But first, let's declare the file. We need a file. We never saw that before. What kind of file? Output file. Why don't we call it track F? And the name of the file is going to be robot100.trk. What this does is that it opens up the file for output. What do you know about files? If I open the peanut butter jar, I got to do what? Close the peanut butter jar. So before the program terminates, we got to make sure that we close the file. Small screen is worrying me. Where am I? Where am I? Where am I? Here. Okay. All right. I'm out of time. All right. So we've got to say close the output file. Close it. And how do you close a file, y'all? How you close a file? We got to close the output file. I'll leave that to y'all. Y'all know how to do it, but it has to be done. And now we have the output file open so that we can output the lines that need to be output. Okay, so let's get going. What's the first thing we do? The stream that we use for this is track file. We're going to output a blank line, because if you look at it over here, it has a blank line, then it has a line that says robot tracker. We're just going to copy and paste, aren't we? And we're going to say output, this output line we just had, skip a line. And what else? We're going to do the same thing again. This is so maddening. Woo. Codio trying to help me here makes it hard to do some simple things. My goodness. I want to output just what was over here. Oops. Just equal signs that match the robot tracker. So let's go back in here. Just a bunch of equal signs. Same number as we have here. And what comes after that? Go back and look. After that, there's another blank line, so let's put that in. Do you get the hang of this? Are you getting this? You just have to pay attention to little things. And now we say what? This line here, this same output that you saw on the screen, you will see again, but this time going to the tracker file, the stream is different. It's not going to the screen, it's going to the file. And with this, I think we have what we wanted to accomplish. So let's go ahead and compile it. I see what happened. G. My bad. Alright, so it says I'm having trouble here. I wonder why we're having trouble. Maybe because we never included F-stream. Let's go back and see if we have F-stream. And we don't. Getting a little long. Alright, let's try it again. It compiles. Let's run it. And we're going to say start. And we're going to go look at this robot.track file, and lo and behold, it looks like we have the stuff we needed to have here. So let's terminate. We're going to run it again to be sure. We're going to delete this file, the track file, just to make sure that when we run the program, it's really being created. So we're going to run it again, see that the file is getting created. We haven't started anything yet, so we're going to say start, look at the file, and lo and behold, the stuff that's supposed to be there is there. Are we cool? And with that, we're going to terminate. So let's recap. We've basically taken the first step and the second step, and we have responded to it by writing to the screen what needs to go to the screen and writing to the file what needs to go to the file. We need to do this for the bad commands. We need to see what happens when the key gets a bad command. We need to see what happens and make sure our program does that very same thing. With that, we're going to end right here.